Good morning. We are Group 8, made up of Francisco Arellano, Andrés Marizalde, Jennifer Murillo, and Danny Tenesac. Background: Kellogg's Company in the production area contains the cereal production area and the packaging area. The packaging area has 4 packaging machines, where the number 2 packaging machine have low availability compared to the others. Problem statement: we made a time series from the January to May, with the availability that, where availability obtained a mean of 64.4%, a rich high value, which we conclude that this availability can be improved. Objective: the objective is to increase the availability percentage of the number 2 packing machine in Kellogg's Company from 64.4%, which is our mean value, to 70% from June to October. Response variable: the percentage of availability is given by the ratio between the difference in operating time and the time of in scheduled stop over the availability time, resulting from the difference in planned production time and the time of scheduled stop. The result will be multiplied by 100%.
Stratification and analysis was made to the company in order to find the different factors with which we can work in the packaging area. The results were the following. The packaging area has 4 machines, the bagger 1, 2, 3, and 4. The most relevant machine stops are changeover times, cleaning times, meeting times, and food safety. Then an availability study was done, which resulted that the bagger 2 having the lowest availability of the 4. Then, to observe what was causing this low availability, we did first a flow diagram in which we observe that the setup, changeover, and cleaning time are quite high. Second, a Pareto diagram was made using the company's record to know what the highest stop times are. This showed us that these are the changeover and cleaning times. For this reason, we decide that in this project we are going to focus on the changeover and cleaning process of the machine 2. Once the stratification is done, we determine that our problem is the cleaning and changeover times, which together represent the 35% of the total packaging time on the machine 2. And our focus objective will be to reduce these times by 50% each one.
A notida was used to diagram the process. The first process is cleaning of bagger 2. There are 8 activities in this process, but 5 activities don't add value, and we will focus in these activities. The same for changeover time. In this case, we have 10 activities, but 2 activities don't add value. Plus, we have 5 hidden factors. For the data recollection plan, we use the Westinghouse table to define how many cycles we need to collect data. For example, the cleaning time is 0.5 hours. So we're going to choose between 3 to 8 cycles. Here we also define the variables to measure, for example, cleaning time, changeover time, activity times, and availability of bagger 2. Measure unit are minutes and percentage. All the data are quantitative and continuous. When to collect, start of measurement phase. Where to measure in the database and packaging area for activity times. Observation method, we have database and direct observation. In collection method, we have historical records and by chronometer for activity times. And way to collect, because we need to know the real times to improve them. Here we also define the amount of the data we need. For example, for y variable, we obtain 7 data. In this case, we use the t-student because the pilot test was of 5 data. To do this operation before, we need to demonstrate normality, data reliability. The company provides us with a database and a small sample was taken by us. To demonstrate that the data is reliable, a mean test was taken where the p-value is greater than 0.05, thus the means are equals. The same goes for the other variables. In this project, the capacity analysis won't be done because we don't have a specification and the process doesn't have modifications.
Stability analysis. But first, we have to do a normality test. We do a control chart for individual data, IMR, because the data is continuous. And as a result, we can see that there is a point outside the control limits, and therefore the process is not under statistical control. And there are common and special causes affecting the process that we have to find and improve to achieve our purpose objectives. Once all this is done, we are ready to our next step in our DMAIC methodology, the analysis. Thank you all very much. See you.